Hello everyone. This is homework 13, slope and rate of change. The idea of a slope is that it measures how steep, let's say, the line is. So it measures its steepness, its slant, or its tilt. The slope of a line can be positive, negative, zero, or undefined. So the situations are if the line rises as we move from left to right, it's like we're going uphill, then the slope is positive. If we have a situation, we've seen all of these before, where the line falls as we move from left to right, then the slope is going to be negative. And then the two special cases. We have the horizontal line, slope 0. So again, that's our special horizontal. We have the vertical line, where the slope is, we say it's either undefined or we could also say that there is no slope. Okay, so those are the four different situations we can encounter. And we have a way of measuring the slope through calculations. We literally define the slope of a point, the slope of a line passing through two different points, x sub 1, y sub 1, and x sub 2, y sub 2. Those are subscripts. They're written to the lower right of the letter of the variable. So that's why we say sub. And they're just meant to indicate different values. So we have one point of xy ordered pairs, another xy ordered pairs, and here's the slope. It's defined literally to just be take the y2 coordinate minus the y1 coordinate divided by the x2 coordinate minus the x1 coordinate. So that's our slope formula, and you will have to memorize that. Whenever we have to mechanically find the slope, that's the formula we want to go to. Now, there's other ways to think of the slope that come in handy, and they are, this little triangle symbol means delta, whereas red is delta. So we read it that the slope is equal to delta y over delta x, and delta just simply means the change in. So the change in y over the change. Or, since y is the vertical change, or up and down, and x is the horizontal change, or left to right, we say vertical change over horizontal change, or something that's going to come in handy as well, rise over run is often a term used to describe the slope. So, as I mentioned, when 2 points are given, then we're going to go to the formula. But I want to first look at an example where we're going to find the slope. So you could write down the slope formula. Once again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You could label these ordered pairs. It doesn't matter which way you label them. I'm labeling the first one x1, y1. A lot of times we won't say sub, so we'll just say x1, y1, and x2, y2. But when you write these, make sure you make those small letters or subscripts to the lower right. And you could label the points like I've done as a crutch. And all you're doing is plugging it into the formula. So you have y2, which is 7, minus y1, which is 2, divided by x2, which is 8, minus x1, which is 7. So therefore, our slope, in this case, is 5 over 7. Now, I want to illustrate with a little sketch here exactly what that means. First, I should label my axes. But I had the points 1, 2, and 8, 7. So let's plot those. 1 and 2, that's right here. And then 8 and 7 would be like right here. And we've got the line that joins those 2 points. Remember, that's all we need is 2 points for a line. We're not given the equation here, we're just given the point that joins 2 points. And what I wanted to illustrate to you was this. If we make a little angle, draw over 8 from there, it was 7. The vertical change and the horizontal change is given by these distances. This is what we call vertical change. Remember, we can call the rise, and horizontal change we can call the run. So the rise here is 5 units, and the run is 7 units, giving us our slope of 5 over 7. So I wanted to illustrate that concept to you. And remember, rise is vertical change and run is the horizontal change. But many times, all that we're asked to do is find the point, find the slope, and we're given the 2 points. So that's what is happening in each of these examples. So just the mechanics of finding the slope. Again, you could label them x1, y1, x2, y2. Get used to writing down the formula. Y2 minus y1 over x2 minus x1. And it's just a matter of substitution. Y2, you can see with the little crutch of labeling the points, is -6, minus y1 is 2, over x2 is 1, minus x1 is a -3. So that gives -8 over 4, and our slope then is -2. So slope could be a fraction, could be an integer. Here's just another one for, I guess, extra practice, because nothing really different is happening here. That is, we're just writing our formula. Again, those are subscripts. If you like, label the points, x1, y1, x2, y2. Doesn't matter how you label them. If you label this as x2, y2, and this guy is x1, y1, it'll still work itself out. But being consistent with the way I've labeled them, y2 is 4 minus y1 and -3 over x2 and -2 minus x1 and -4. So it looks like we get 7 over, this would be -2, minus a minus is plus, so -2 plus 4 is 2. Okay, so moving on, we have something that looks the same, but we'll see when we do our little calculations that might be different than what we expect. We're still going to consider just labeling these as x1, y1, and x2, y2. And we write down our slope formula. Again, y sub 2, y sub 1 over x sub 2 minus x sub 1. And we show our substitutions. So we get y2 is 7 minus y1 is 7 as well, over x2 minus 5 minus x1, which is 3. But notice that in the numerator we get 0. And in the denominator we get negative 8. Really doesn't matter because 0 divided by any number we know is 0. And basically what happens here, we know if we get a slope of 0, we should know right away that it's a horizontal line. But if you wanted to, I'm just going to kind of give a rough sketch here, so I'm not really going to scale things off too well. But just to illustrate the concept. Okay, 3, 7, let's say, is somewhere over here. 3 and say y is 7. That's a point. And then let me extend this axis a little bit more, try to get it somewhat to scale. Doesn't have to be to scale. But then negative 5, so maybe over here, and 7, that's another point. And you can see they line up in the same horizontal line. And notice that you could tell pretty much by inspection that something's going on because the y values are the same. And if you recall, that's actually the equation for a horizontal line, is when y equals some number. Number is 7. So that's actually the equation of that line. Now similarly here, you might think something is going on because now you see the x coordinates are the same. Now if you understand how to find these special lines without having to calculate the slope, that's great. But you could still actually go through the formula for the slope and determine the same thing. That is, the same situation that we get in terms of with regards to a horizontal or a vertical line. Because if you plug in, the way I've labeled it, y2 is 5 minus y1 and minus 2 over x2, 4, 6, 1, 4. That gives 7 divided by 0. But divide 0, we say it's defined. So if this was undefined, we know it's vertical. And you could see that literally if you point. That's y and this is x. See, 4 and negative 2, let me just call that 4, I'll call this negative 2, it's right there, and then 4 and 5, let me call this 5, that puts me up here, and you can see that those points join a vertical line. And since the x coordinates are always going to be equal to 4, that's actually the equation of that line. X equaling 4. Okay, so here's an example where we want us to use the points on the graph. So what we first identify, what are the ordered pairs for those 2 points? So we have to read them from the graph. So this point that's in the, I guess we should have labeled x and y here. But this point that's in the second quadrant, see, it looks like it's on the point where x is -7 and is positive x. And then similarly reading this point, x is +6 and y is -4. So the 2 points, -7, 6, and 6, -4. And if you want to label them with the little crutch of x1, y1, x2, y2, and go to the slope formula, which again is y2 minus y1 for x2 minus x1, and just simply plug those values in. And we have y2 is a -4, minus y1 is 6, over x2, which is 6, minus x1, which is a -7. And so now that gives us -10 over 13. And the interesting thing is, remember, we defined our slope as rise over run, right? That meant vertical change over the horizontal change. And to get one from one point to the other, just sketch this out. You don't have to really worry so much about this, but just making a little right triangle out of this, out of these 2 points. You could see, if you counted, to get to this point right here, which is the point -7, this is your run of 13 units, and this represents the rise of -10 units. But see, it's negative because if we start at this point, we first go down 10 units and then to the right 13 units. So it's a negative change in y and a positive change in x, hence the slope is negative. Okay, so recall that we have the general form for the equation of a line. It has x's and numbers, x's and y's and a number. If we actually solve for y in terms of x, we obtain a very special form, and that's referred to as slope-intercept form. And so we define the equation of a line with a slope of m and a y-intercept of b is given by, I'm sure you've heard this before, right? Y equals mx plus b. So that's literally the equation of a line. If y is isolated, if we solve for y, that is literally the equation of the line, where we can tell then by inspection what the slope is, as well as the y-intercept. So notice how they match up. That is, this 3 represents the m, in the formula, and the 5 represents the b. So as long as y is isolated, we just tell by inspection that the slope is 3 and the y-intercept b is 5. But that y-intercept b is at the point where x is 0. So I'm going to state it that way. I'm going to say b is 5 at the point 0 and 5. And it doesn't matter, you can have decimals. Excuse me, you could have fractions. Just matching things up. X plus b, or just m 8.5, and the y is 0, and y is 0.87. So it doesn't matter, but it does matter that y is isolated. In both those examples, it was easy because y was off on one side. It was, remember, we called it explicit form, where y was given explicitly in terms of x. But in this case, that's not. So we may have to solve for y in terms of x. So in this equation, I think I'm going to copy it over. 2x plus y equals 8. If I want to get y alone, I have to subtract 2x from both sides. And then y will equal, and we cannot combine the 8 and the negative 2 here. We literally have to write it as two terms. I'm going to put the x term first, so I'll write 2x, and then I have to separate the 8, because they're not like terms, you have to separate with a plus. And so now I can tell by inspection. So now that y is isolated, now consider mx plus b form, and the fact that all you're doing is matching them up, right? M, the coefficient of x, in this case negative 2, and b, looks like it's 8, at the point where x is 0 and y is 8. Okay, and then the final page, horizontal and vertical lines. And when something is missing, one of the variables, you know it's a special line. So it does not have a tilt to it. And so whenever you see just either x equals or y equals, my suggestion is make a sketch. We want to know what the slope is here. You know it's a special line. Did you memorize that it's vertical, or did you memorize that it's horizontal? Or just build it with the analytic geometry. If y is 7, then y is always 7. That means that I can move left or right along the line where y is 7, and I maintain that y value. But if I move up or down, it would change y, and that's not allowed because we were told that y is 7. So by inspection of that line, we can see that it's horizontal. And when we have a horizontal line, the slope is 0. Because we're not moving uphill or going downhill, we're on a flat surface essentially. So right away again, in number 5, I recognize it as being a situation where the fact that the y is missing means it's special. It's a special line. So again, if it's got just x or y in it, it's special. Did I remember if it's vertical or horizontal when x equals? No. I'm just going to make a sketch to prove to myself what's going on. And if x is 5, just say somewhere over here is 5, that's a point for sure. Also, any point that is in a vertical line would have x equaling 5. See, I can't move to the left or to the right here. If I move to the left or if I move to the right, then the value of x changes. So if x is always going to be 5, the only thing I could do is either move up or down, but staying along that same vertical line. And recall that when the line is vertical, it's probably best to just say the slope is undefined. Because if you start saying no slope, you might get mixed up with a line that has a slope of 0. So it's best to just stick to undefined slope when it's vertical. And here, you see the words hoy and vux. And this gives you the characteristics, including the equation. I should have actually said here, well, I mean, we included the equations were the givens. But this gives you the characteristics, including the equation of the lines, these two special lines. That is, LH stands for horizontal. Okay, that O doesn't stand for the letter O. It stands for the fact that the slope is 0. And the Y is the equation. Y equals the symbol. Y is some number. Will give you the equation. Actually, let me call it, instead of the pound symbol, let me typically use what's used. That's the letter B. Okay, and then the other situation is Vux. Just move it over so I have more room to talk about it. Okay, for Vux, you have a vertical line. And slope, I like to say it's undefined. X represents the, and the equation is always x equals some number in general, I'll call it A. So the Hoy Vux is helpful because if you know how to use it, then it's going to tell you the main characteristics of a horn vertical actively. The rest, we talk about parallel and perpendicular lines. Parallel lines have equal slopes, and the best way to talk about perpendicular line give reciprocal slopes. So in each of these problems, we want to find the slope of a line that's parallel to and perpendicular to the line with the given slope. And so in one slope is 2/7. And so the slope parallel, the slope is also 2/7, and in part B, perpendicular, Okay, it's the negative reciprocal. So negative means the opposite, reciprocal, flip it over. And so if we have 2/7, 3/2, and the opposite is negative. So when we're given a slope like this, -3, and you have to find the perpendicular, you may want to write it as a fraction over 1. Parallel's easy. The slope is just the same, -3. But perpendicular, it's the negative reciprocal. So that's why I put it over 1, so when we flip it over, we get 1/3, and then the opposite would be positive. Okay, so then the final question are classics. There's 2 examples here, and we would just want to find the slopes of parallel and perpendicular lines that pass through these points. See, what the idea is that parallel lines look like this. Their slopes are equal, so they never touch. But perpendicular lines, their slopes cross at a right angle. Oh, I'm sorry. I was drawing this up here, and I wasn't showing you. So parallel again, both slopes, you can see these will never touch, and perpendicular cross at a right angle. Okay, so getting back down to our examples, here's where things we were doing earlier: x1, y1, x2, y2, calculate the slope, y2 minus y1 over x2 minus x1. Slope would be, plug it in, y2 minus 1 minus y1, 5, x2, 3 minus x1 and minus 2. So it looks like we get -6 over 5. So then answering the questions, part A, parallel, slope is the same, -6/5, and then part B, perpendicular, negative reciprocal. So flip it over, 5/6, take the opposite of the negative as positive. And then finally our last example, okay, I'll label the ordered pairs. If you don't want to write down the formula multiple times, that's fine. Just start the substitution process if you like. Okay, so y2, the way I've labeled it, again, make it, use a little crutch there, 7 minus y1 and minus 2 over -1 minus, that's x2 minus x1 is a -4. So we get 9 over, it'd be -1 plus 4, so 9 over 3, or 3. So for the parallel case, slope is going to be the same, 3. But then for the perpendicular case, the negative reciprocal. And if you want to make it 3/1, so you see it as a fraction, and then reciprocate, flip it over, take the opposite of positive is negative. So -1/3. Okay, so that's the end of homework 13, and we'll see you when you're ready for homework 14.